In this video, we'll see how we can use Canvas to perform some more complicated tasks. We'll begin by calculating fingerprints for our structures, and then we'll use that information to cluster the compounds according to similarity. Again, as was the case when we calculated descriptors, we'll begin under the Applications menu. For the fingerprint calculation, we'll want to choose the Binary Fingerprints option under the Applications menu. This opens a panel that allows us to set a few options before running the calculation. Some of the options that we can set in this panel, such as whether to calculate fingerprints for selected rows or all rows in Canvas, are self-explanatory. Other options are very specific to the type of calculation we're running. In this example, we'll generate dendritic fingerprints as opposed to structural keys. So we'll keep the default setting of hashed fingerprint types and choose dendritic from the list of possible options. Finally, to actually run the calculation, we can type a unique name that will eventually appear as the title for our new fingerprint column, and simply click the Create button. As we saw earlier when we calculated descriptors, the name of the running calculation appears under the job type in the Project View pane. Once the job runs to completion, we can right-click on the job name and choose Incorporate to bring the results into our Canvas table. And here at the rightmost end of the table, you can see that a new column has been added. There's not much that the naked eye can really discern from the bit string that's produced by the calculation. So instead of clogging the table with zeros and ones, Canvas just lists the number of bits in the fingerprint. Now that we have fingerprints, we can put them to good use by using them as input for other types of calculations. For example, we can perform a hierarchical clustering calculation using fingerprints. To do that, we head up to the Applications menu and choose Hierarchical Clustering. Again, running the calculation is relatively straightforward. As we've seen before, we can choose to cluster either all rows in the table or only the selected rows. In this case, we'll use all rows, which means that we'll be clustering every compound in the table. We can also choose the name Canvas will use to save our results. We'll just use the default name for now. If we've already created several different types of fingerprints, we can choose from among them here in the fingerprint column setting. There are also a number of important options pertaining to how similarity is actually calculated. The most important of these options is metric. It's the method that's actually used to compute similarity. As you can see, there's a considerable number of methods we can choose from. In this example, we'll just use the default Tanimoto similarity. If you want more information, you can click the Formula Key button. This will expose a window that describes what the terms in the description field actually mean. To run the clustering calculation, we'll just click Create Clusters, and, as usual, the job will run and we can see the status in the project view. However, this time we don't right-click to incorporate the completed calculation, because we're not incorporating properties into the table. Rather, to visualize results in the form of a dendrogram, we can either double-click the completed job name or right-click and choose View. As we visualize the dendrogram, we can scroll from left to right using the bottom scroll bar. Let's get started though by adjusting the number of clusters that we'll visualize. I'll set the value in that field to 5. As you can see, each cluster in the dendrogram is colored differently, and they need not have the same number of member compounds. In the top of the window, you may have noticed that Canvas displays the merging distance value that was used to create the specified number of clusters. We can adjust the merging distance by clicking the toggle for that setting and typing a new similarity threshold in the appropriate field. Let's set it to 0.5 and see how that affects things. As you can see, the number of clusters is greatly increased, and we now have 18 clusters. In fact, some of these clusters consist of only 1 or 2 compounds. Clicking on one of the cells at the bottom of the dendrogram will allow us to see the compounds in any given cluster. Here's what it looks like when I do that. The cluster members are presented as a list of structures. In this cluster, you can see that the compounds are all rather similar, and if we like, we can save this specific class of compounds, this cluster, for future work by saving the cluster as a custom view. To do so, we choose Save As under the View menu. When we type a name and description for our custom view, it helps to choose something descriptive. For example, the cluster number and the clustering options that were used. After we save our custom view, it's available in the Project View pane under the list of views. Now, let's take a look at how to perform fingerprint calculations and hierarchical clustering calculations within a live demonstration. To get started, I'll head up to the Applications menu and choose Binary Fingerprints. And I'm going to create these from structures in the main canvas table. So the first thing that I'll do is I will type a name for the new fingerprint column that we'll be creating here. And in this case, I'll do radial fingerprints, so I'll call it radial FP, and I'll choose this radial toggle right here, and go ahead and click Create to actually run the fingerprint calculation. Once that happens, under Binary Fingerprints in the project view, you can see that the job status is running, and in just a moment the job will complete. So the calculation is run to completion, and to add the results to Canvas in the main table, I'll just right-click and choose Incorporate. Over here at the rightmost side of the Canvas table, you can see the radial fingerprints column appears, and we've got a bit count in place of the actual bit string, which would be rather visually indecipherable. So the next thing that we're going to do, now that we have our fingerprints calculated, is to perform that hierarchical clustering calculation to take a look at that dendrogram. Under the Applications menu, I'll choose Hierarchical Clustering. So I'll just use the default job name here, and under this menu, this drop-down list of different fingerprint columns, we've only got the one fingerprint column to choose from, which makes that choice rather easy. The other big choice in this interface is which metric to use. And as you can see, we've got a few more to choose from here, but I'll just go with the default choice, Tanimoto similarity. If you want more information on what it is that you're choosing, you can press Formula Key. And you can see that brings up a dialog that explains a little bit more about what all the terms in this description field here actually mean. So I'll close this dialog, and I'll go ahead and press Create Clusters to go ahead and run that hierarchical clustering calculation. Again, over here in the project view, under hierarchical clustering, you can see that the clustering calculation is already finished, and this is something that doesn't actually get incorporated into the table at left here, but it actually appears in its own separate window. So I'll just double-click on this to open up that window. And you can see as we scroll from left to right across the dendrogram, the entirety of the dendrogram. So the first thing that I'll do is increase the number of clusters. I'll bump it up to, say, 4 different clusters right here. And you can see that when I do that, the merging distance is adjusted over here. It might be a little bit difficult for you to see because the field is grayed out. It's not editable right now, but it says about 0.9 is the merging distance that was used to create these 4 clusters here. If I want to take a look at what the contents of any of these individual clusters are, I can just click on one of the cells at the bottom of the dendrogram. Hovering over that cell, as you can see right here, displays a little pop-up window that shows exactly what the structure is. And then clicking on it opens up that window that contains all members of Cluster 2. So I'm going to go ahead and save Cluster 2 as a custom view. And under the View menu, I'll choose Save As. I'll call it Cluster 2 of 4 Radial Fingerprints. And ordinarily, I would type a description here, but in this case, I'll just go ahead and press OK to save my custom view. You can see that the custom view opens in its own window. I'll dismiss that, and I'll dismiss this window that shows the original cluster after we had opened it up. And I'll just slide this out of out of the way to go ahead and draw your attention to the project view where we see cluster 2 of 4, that custom view, actually saved in the project view. So the last thing that I want to show you here is just how to adjust the merging distance. And to do that, I'll press the toggle for merging distance, and I'll drop it down to about 0.5 for this example and press Update. So you can see that we now have quite a few more clusters in the table right here. We've got a grand total of 105 clusters, so you can see that things suddenly become very discrete when we do it like this. The absolute final thing that I want to show you is just how to export our dendrogram. We can do that by clicking on Export, and that just opens up a simple dialog right here that allows us to send it to a file or a spreadsheet. It's just that simple.